Hello, welcome to the next section, linear and logistic regression. In this section we'll first learn about regression, then we'll learn about linear regression and implement it, and finally we'll learn about logistic regression. Now we move on to the first video of this section, regression analysis. We'll learn about regression analysis. So let's ask the fundamental question, what's a regression? Before all considerations, regression is basically a statistical process. Regression will involve a set of data that has some particular probability distribution. In summary, we have a population of data that we need to characterize. There are a large number of function types available to help us model our current data, the most common example being the linear, polynomial, and exponential. These techniques will aim to determine an objective function, which in our case will output a finite number of unknown optimum parameters of the function, called parametric regression techniques. Let's now look at applications of regression. Regression is normally applied in order to predict future variable values, and it's a very commonly employed technique for initial data modeling in data analysis projects. But it can also be used to optimize processes, finding common ground between related but dispersed data. Here we'll list a number of the possible applications of regression analysis. In economics, to predict future inflation rates, interest rates, and similar indicators. In earth sciences, to predict future phenomena, such as the thickness of the ozone layer. To help with all the elements of the normal corporate dashboard, adding probabilistic estimations for production throughput, earnings, spending, and so on. Understanding how sensitive a corporation's sales are to changes in advertising expenditure. Seeing how a stock's prices is affected by changes in the interest rate. In social sciences, to predict the future values of all kinds of metrics, such as unemployment and population. A very important distinction we can make to recognize how appropriate the problem variables are is by dividing the data types into quantitative and qualitative data variables. Now let's address the question of which types of variables are suitable to apply to regression problems. The clear answer is quantitative variables, because the modeling of the data distribution can only be done through functions we use to detect a regular correspondence between those variables, and not on classes or types of elements. Regression requires one continuous output variable, which is only the case with quantitative metrics. In the case of qualitative variables, we assign the data to classification problems because the very definition of it is to search for non-numeric labels or tags to assign to a sample. That's all about regression.